Hello friends. So today's topic is trigonometry. This is going to be a little longer topic, so I will be putting the videos in different parts. So I will not put like everything in one video and make it a little longer. So let's start with having a right angle triangle. So we have a theta, we have a perpendicular, we have a hypotenuse, and we have a base here. So we know that sine of theta is perpendicular upon hypotenuse. Cos of theta is base upon hypotenuse, and tan of theta equals to base upon perpendicular upon base. So perpendicular upon base gives the tan of theta, and it depends on which theta you are looking at. So there are two angles. So now we are determining all these values in respect of this angle. If you take this angle, then this would become the base and this would become the perpendicular. So it depends on which angle you're looking for. So this angle now, so this angle's perpendicular is this, base is this. So it always depends on which angle you're taking. And we know that reciprocate of sine theta is cosec theta. So cosec theta would be hypotenuse upon perpendicular. And similarly, sec theta is hypotenuse upon base, reciprocal of cos of theta. And cot of theta, base upon perpendicular, this reciprocal of tan of theta. And we have been learned about these simple identities in 9th or 10th standard, which is sine square theta plus cos square theta is equals to 1. Second is 1 plus tan square theta is equals to sec square theta. And third is 1 plus cos square theta equals to cosec square theta. And there are different identities which would come into use is a square plus b square plus c square equals to ab plus bc plus ca. A equals to b equals to c. Important. Next, let's have an example. Sec square a minus 1 into cot square a. So tan square a into cot square a. And now tan and cot are reciprocate of each other, so it is equals to 1. So this sec square a minus 1 comes from here. 1 plus tan square a equals to sec square theta. and cot square A is like, we know that tan and cot are reciprocate of each other. So if I want to write cot square A, it would be 1 upon tan square A. So tan square A into 1 upon tan square A. So tan square A cut by tan square A equals to 1. So like this, we can use these different identities. One more example I would like to take is tan square A sine square A. Tan square A minus sine square A. So this would give tan square A sine square A divided by sine square A sec square A minus 1. So this sine square A gonna cut with sine square A, and sec square A minus 1 equals to tan square A. So this way this gives 1. So here I'm using all these identities, mixture of them, and by them I'm solving these questions. Now sometimes there are like questions like prove the following. Prove. So first is sec theta plus cosec theta multiplied by sine theta plus cos theta. We need to prove it. It is equals to sec theta cosec theta plus 2. So sec theta, I can write it as 1 upon cos of theta. Cosec theta, I can write 1 upon sine of theta. And I will keep it as it is. So always when you see trigonometric questions, try to break them down so that you have less variables. So like there were 4, I now reduce it to 2, sine and cos. So this will make your questions to solve it easier. So now this is what? It gives sine of theta plus cos of theta upon sine theta cos theta. And multiply by sine of theta plus cos of theta. So we had sine plus cos divided by sine cos multiplied by sine plus cos. Now to this I can write as 1 plus 2 of sine cos divided by sine cos. It's simple, I just open the brackets and solved it. Now I can write as 1 by sine cos plus 2. Yep. So just 1 upon sine cos and plus 2 sine cos divided by sine cos. Sine cos by sine cos is cut. So 1 upon sine cos plus 2. Now I can write it down as sec into cosec theta plus 2. So we proved. Hence proved. There is one more complex question I would like to discuss here is cosec square A multiplied by cot square A minus sec square A tan square A equals to 0. So we will take let A equals to tan square A, B equals to cot square A. So now these assumptions, these comes by practice. You need to solve more and more questions. So then you will be able to click like what you need to take as A and what you need to take at B. Because most of the times students get confused like how it's gonna click, like why I should take A equals to tan square A or B equals to cot square A. So this comes with practice because you need to, I'll show you the solution and then I'll let you know why we took like this. So what it becomes is 1 plus B multiplied by B So this whole equation turns into this equation. You can pause the video, you can check how it is. So I have basically used the 3 identities I've mentioned before. And so now it would be much easier to solve in this form. P plus so just opening the brackets, nothing else. So here comes B minus A B square minus A square minus B minus A and this is positive, you know. So now I'll take just B minus A. It will give me 1 plus B plus A. Let's take this as whole minus 1 plus A plus B. So this is 1 plus B plus A, and this is negative of 1 plus A plus B. So this whole cuts down by this. So it turns out to be 0. So something multiplied by 0 so B minus A multiplied by 0 is 0. Hence proved. So to make this equation simpler, I took A equals to tan square A, B equals to cot square B, because then I can change the whole equation in A and B. As I told you in last question, that try to take less variables and turn down the equation into lesser and lesser variables. So I turned the whole equation into two variables and then solved that equation, and it gave me the answer. So always try to come up with the idea where you can break down the other things into those variables. Now there is one more very interesting question. You can even like make it a note, because this is asked very oftenly. Sin x plus cos x So this kind of proof is very often used. You will see this as a part of a bigger problems. You will counter with sin x plus cos x divided by cos cube x a lot of times, and then you can use directly this proof that it is equals to tan cube x plus tan square x plus tan x plus 1. So how we prove it is, take sin of x by cos 3x plus 1 by cos square x. So just separated the terms. This is equals to tan of x multiplied by sec square x. So 1 sin x divided by cos x converted into tan x. So I was left with cos square x at the denominator. When it goes into the numerator, it is sec square x. So tan x sec square x plus 1 plus tan square x. And this is sec square s. So now tan of 1 plus tan square x plus 1 plus tan square x. So this cos square x goes up, it is sec square x. Sec square x I have written as 1 plus tan square x, and this sec square x is also 1 plus tan square x. So I have taken tan common, 1 plus tan square x plus 1 plus tan square x. So tan of x plus tan cube x plus 1 plus tan square x. So here comes tan cube x plus tan square x plus tan x plus 1. That's proved. So it was pretty simple. I will go again. Sin x plus cos x divided by cos cube x. So I've written like sin x divided by cos cube x plus 1 upon cos square x, because 1 cos x is cut by 3 and it remains 2. After that I have written it as sin x divided by cos x is turns to tan x. So I was left with cos square x, which turns to sec square x in the numerator. Now the cos square x goes up, it is sec square x, but I can write down sec square x as 1 plus tan square x. So I have written 1 plus tan square x. Similarly here, sec x I can write as 1 plus tan square x. So this comes from here, 1 plus tan square x. So when we multiply this, tan x plus tan cube x plus 1 plus tan square x. So here is hence proved. Now there are some important note. First is cos 6a second is cos 4a plus sin 4a equals to 1 minus 2 sine square a cos square a.